Hello, 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 hi guys. Hello guys. Welcome. Wait, let me put my chair to one side so that it doesn't disturb. Okay, okay. Mic is on, music on. Okay, let's do Linux Sling. Linux Sling. First, this is the frame. The frame I have already installed. Why? Because I this frame is self-sourced, so there's no uh thread inside the extrusion. So I have to use the corner joints here, as you can see. That's why I install the frame first, because this is very easy. Just install the corner joints at the corner here. So you got the frame here to be set up in front here like this way, in front of the printer, right? Like this, all right. So basically that's it. Let me open up the fusion. Okay, so that we can see together. First, I think we need to install this bracket. Is it this bracket? I think we install this part here first better. What do we need here? This piece. And then let me just try to. Okay, what hardware is this? M5 by 8, M5 by 10. So we need the M5 by 10 4, M5 by 8 2. M5 by 10 4, M5 by 8 2. All right. M5 by 10 4, M5 by 8 2. M5 by 10 I have. Wait put down here first. M5 by 10. M5, M5 by 10 4. 1 2 3 4 3 4. And then we need M5 by 8. Here don't have M5 by 8. So M5 by 8 is inside here. Get my screw. This is 6. This M5 by 8 2. Yes. I need to make a screw box. Okay. I think we also need the alamak. Oh no, correct. We also need the T-nut. Let me see. I can get some T-nuts out. Get some T-nuts out. Okay. So this one will go. I think this one we just use normal T-nuts. So we will need this part down here. This one later. What are the parts that we need? Oh, this one. 1, 2. Right. So this one going to use and 5x8 to is here. Then we can use just normal thin drop in nuts. So this is going to be this way. Right. For the top here, I think we use this draw in nuts better. Yes. Okay. And 5x10. All right. Draw in one more. 5x10. Okay, looks like here is settled. Let's do the other side. I want to drop all my screws. Put down here first. So here we have this same part. What's this? M3. How come this one M3? Fire in it. Okay. M5x10. I think this one very fast setup. Because this one previously done already, but this is just some improvement and changes to the drive system. We are using belt now. All right. So we have this side fixed, this side fixed. Both sides are fixed. Now, let's do the bracket. Let me check the bracket. Bracket is using, here is using what? M5 by 8 and M3 by 8 put a washer. Okay. M5 by 8, M3 by 8 put a washer for the bracket. M5 by 8 is same thing inside. Yes. Where is it? Is it this one? Yes. M5 by 8. Looks like so short. Yes, correct. M5 by 8, 1, 2. And then M3 by 8 I have. Again. Okay, M3 by 8. And also I need the washer. Let me just put this one side. Need M3 washer. 1, 2. I think I need a bigger washer. My cat. Oh man. Okay, let's put it back. Okay, here we have sorry, M3 by 8. So we need also the shit. We need also the not M3 no need M5. M5 I think we can use just the normal drop in nut. 1, 2. Okay. So I will go in this way. What's the point? And the hole is like too far. Did I do something wrong down here? This one, the hole is like too far out. Hmm. Oh yeah, can. Correct, correct. Right. Need to do one more here. Okay. All right. Hey, Gurkman. No, this is ender wire. It's a ender 3 converted to an ender wire. Previously, I already built this Lineux Sling using this, but the dog slide is using pinion and rack previously. So now we change everything to use belt instead. So that's the only difference. And also the tool head I'm using will be different as well. Testing out the new tool head as well. So one side done. Now I'm doing the frame for dog slide, for our dog slide down here. So I need another M5 by 8. M5 by 8. Yeah. This is M5 by 10. Okay, I need the 1, 2, I need M3 by 8. 2, 2, and I will need washer as well. Cyber boom. Oh yeah, I saw that as well. It's a Core XZ, right? Cyber boom. Yeah, I think it's possible as well to turn it into, to build dog slide as well, to turn it into a tool changer. I think it's very, very possible. You just, I mean, of course you need to do, but you also do. Oh yeah, but since it's core exact, the travel will be very fast. So I don't see why not. It's very easy. Just the file are in our GitHub. You can just download the file and take a look if you want. Stock marlin. Oh yeah, you need to, yeah, you need to run Clipper with that, because I don't know others about others, but our BTC runs on Clipper, so you need to convert it to Clipper. You need to flash it to Clipper. But I mean, that's all very easy as well. I mean, just need to flash it to Clipper, and basically you can do it already. You can have a look, try to take a look, and then see whether it's feasible to change. I mean, for this right now, this is the stock and the 3 size converted to an under wire. I can fit 4 tool head. That's why I have the 4 tool head ready down here. All the 4 tool heads are ready except for the 2 of them. 2 of them need new stepper motors. So I'm waiting for the stepper motors. This should be possible. Cyber boom. You know what? Actually, I did send them an email as well. Cyber, regarding that Cyber boom. I want to install Linux on Cyber boom. See whether they are willing to send us one. But no reply from them. I think I'm not that big to get a reply from Cyber. But I intend to have this running on all Bedslinger if possible. Yep, correct. Anything, just put a pi, run Clipper, you can run almost anything already. Even in our Discord, someone wants to run Prusa Mini using this dog slide system. Let's see how the person do it. Oh, this is the wrong screw. Why this one cannot go in again? I think it's the wrong Wrong peanut. Wrong size peanut. Okay. This should be the one. Yes. This time round is much better. Yeah. I mean, even I myself, I use orange pie. Orange pie, much easier to get, much cheaper. Orange pie, or maybe just get big tea tech. See whether it's feasible for you. But really, yeah, this Raspberry Pi are very expensive. Why is this thing not biting? Hmm? Is it because it cannot reach or what? This M5 by 8 is too short. Maybe I use M5 by 10. M3 by 10. Do I have M3 by 10 now here? No. Let me use M3 by 10 screws. M3 by 8 seems like too short. See whether I have M3 by 10. I should have M3 by 10. Oh, okay. I remember M3 by 10. Oh, yeah, this one. 3 by 10 is in. Yes. Oh, yeah, the Trident R2, right? Yes. I don't have the Trident myself. I myself don't have a Trident. I only have the VisiBot. I thought of converting it to a Trident, but my brother decide. He says no. He advised me not to. So I just stick with VisiBot because now I have the other 2.4 running Linux as well. The V2.4, and this will be the Bedslinger. And after that, I will reboot the VisiBot. So after that, all is complete, and then hopefully I can start to save up some money to get a Trident. The R2 belting path, all everything, the new upgrade all looks good. I just wish they convert it to a belted Z, but they are still sticking with the lead screw. Lead screw is something that I don't like very much. I have bad experience with cheap lead screw. But you know, if you buy the kit, of course, the kit should have a better lead screw. Okay, so now everything seems to be fixed. The frame is fixed. Okay. Uh, let's check the cat. Okay, now the frame all has been fixed. So, okay, I think let me install this this thing first, because this thing is taking too much space in my box. Let me remove all the spools, and we see what screw it use. Here is M5 by 15. Don't know whether I have M5 by 15. And then this M5 by 10. M5 by 15 and M5 by 10. Okay. Yeah, correct. Lead screw. I mean, there's nothing wrong with lead screw if you really have those high-end ones. There's nothing wrong with lead screw. One thing is, of course, the speed is much slower than belted Z. But I mean, since they prefer to use lead screw, You have you have to follow them. You use lead screw. I mean, hopefully someone do a mod for it and go belted M5 by 16, M5 by 15. Sorry, M5 by 15 and M5 by 10. Here got M5 by 10. 5 by 10. So left right I would need 2 M5 by 10. And also I will need to this as well. Yes. And then I need M5 by 15. Let me see, I have M5 by 15. If I don't have this M5 by 15, then I have to just skip this part first. What's this? This is M5 by 10. So these two are the same. What's this? Yeah. Okay. Got M5 by 16 times 2. Eh? Here one, yeah, correct. Then we will need the T-nut as well. Yeah, of course. But I think they are going to be releasing it very soon, right? Like like what Steve said, not Voron soon, real soon. But Voron soon, real soon. Huh? Okay, what is this part just now? Oh, this. Okay, this will be the spool mount. This will be down here. Okay. I think this will need to go through here all the way. Okay, we need to put in the drop a hammerhead nut. The drop in T nut. Let's see. Okay. Means we can use this nut. Okay. Right. So this one has gone in. Alamak. Should I put in this first? Oh, I can. Yeah, this way. But cannot. Yep. Yes, correct. I mean, index is getting very, very popular now. A lot of people are talking. It's the talk of the town. Index. They have already showcased a lot of printers as well, right? The Trident, Prusa. So even Prusa has been taking orders now. So looks like everything is confirmed for them. Hmm? Oh, this one is like, wait, is it going in somewhere? Right, right. Woo! Yeah, yeah. Of course, man. Prusa, what do you expect? But this costing I mean, right now it won't be an issue for them already. Because some might find it cost expensive, all this, but I'm sure they will just buy it. Shouldn't be a problem for them. This costing. Oops, I dropped my. Uh, very hot man here. No aircon. Wow. Wow, you have a snack maker. How's snack maker? I heard very good review about them. There, I mean, some video I saw, this guy was doing thousands of tool changes, thousands of running hours on it, and still running without any problem. But I mean, now a lot of people are moving to tool changer with the amount of designs coming out DIY. So a lot of people are moving to tool changer instead. And for those who already have printer, building a tool changer is much better for you, for people who like to tinker, right? Building a tool changer is better. You have time, but of course it will cost more than if you buy just a snap maker you want. But for me, I prefer to do things like this, design my own. So that's my way of doing it. Oops, I think I better put this one at the bottom first. Yeah. Even stealth changer, you can see now, even LDO with their kits. I mean, a lot of people have bought LDO stealth changer kits now. So even those companies come out with tool changer as well, DIY tool changer kits are still popular. Yeah. So I mean, software issue is not a problem. I mean, that's down to Snapmaker itself. But if the hardware you don't have any problem, then it's good enough really. That is more important than software. Software, I mean, they can easily fix it. But if the hardware is good, that is the most important thing. I wish I have a Snapmaker also. Because I like it, but I want to I want to compare with Linux because ours is tool changing much faster. I want to compare the timing, how fast Snapmaker can print compared to Linux. So I want to compare between both. That's why I want, if can, another uh, consumer tool changer to compare. Yep. This is a much easier project since you have the cyber boom. And for toolhead, this if this works like it should, this is comparable to Snapmaker you want because it's 4 to 8 as well. 4 to 8 as well. And this is the first Ender 3. I mean, if you go to eBay, you can get an Ender 3 for less than $100. Then you just install this, you get equivalent to Snapmaker. I'm just waiting for Oka to have the Spectrum, because I tried the Snapmaker Spectrum. I cannot get it to install. I cannot get it to work. So I'm just waiting for Oka Spectrum, Filament Spectrum. Yeah, it's such a waste, Imagine. This Android 3 actually, ever since I bought VisiBot, this Android 3 has been sitting and collecting dust. It's very, very dusty already. Even the rails now, when I converted to this underwire, the rails now all are some are rust. LDO wanted to sponsor us these rails, to change all the rails, the three rails, XYZ, and also send me the extruder stepper motor. So hopefully I get it soon so that I can quickly build up this thing. Right. So the spool holder, I need to get this. Hold on. This is the first mod that I did for Ender 3 is the double Z using two lead screw. The first mod that I did. So I have two lead screw. So this is what we're going to use for the spool mount. Yes. Oh, just nice. This is just nice. Do I have another longer one? Maybe on top at my bed. This one is just nice, the length, 300 by 300. So the spool will sit down here. There's a spool roller down here. So the spool, all the four spool will sit down here, all right? So far looks good. Let's remove that first. Just making use of whatever things I have. Back mod on the N4 Max when I get a time. Oh, since they are on rails, make it much more easier. Oh, by the way, this one I think, I don't know whether you guys know that the clicky has been changed to servo mounted on the gantry instead of on the frame, so that when you home XY, you just need to pick up the clicky and then you can home the Z. So it's much more easier than having the clicky on the frame itself. Okay, so the spool mount has been mounted. Let's turn it back around again. Uh, what kind of difference do you mean? Normal switch wire. Oh, any difference in the... I don't think there's any difference. Because this one is almost the only difference is some of the original frame extrusion. Like the one for the Y here is 2040. So that's the only major difference. But other than that, the whole setup, the whole kinematics, everything is the same as a switch wire. Maybe the dimensions could be different. I'm not very sure. But still it's easy to just edit a bit inside Fusion. So not a problem. Seaboard boom has tap. Using tap. Uh, tap is good. I have tap. My Linux is running tap on the Voron 2.4 R2, but thanks to cartographer for sending me a V4 probe, cartographer probe. So I will be changing the tap to use a cartographer probe instead. Since the previously why I like tap is because of the nozzle probing, but since now Kato and Beacon has also tap touch, Beacon touch, right? So I want to change and use that instead. It much faster, faster probing, everything is faster lah. but I have yet to think about how to mount it. I know I have uploaded the mounting for beacon and Kato. I thought I want to change and mount it on the carriage, but if you see inside Discord, I already asked that it cannot be disconnected. So I have to mount it on the tool head as well, and then I will see how it goes. Yes, I mean it should be very very fast. This is the first time I'm using a current eddy current, so I don't have eddy, I don't have beacon. Kato is nice to send me one, so I get to test them and hopefully use that as our base. Okay, now let's mount the motor first. Let's mount this side first. Motor. So motor we will use M3 by 10 to M3 by M3 by 10 to ni. Okay. So M3 by 10 to M3 by 10. This is M3 by 8. So I need M3 by 10 to, and also I need the M3 by 10 is inside this one. Yes. So for motor left and right, I will need 4. 1, 2, 3, 4. So M3 by 10, 4. Now we will need the, see this, is this M40 nut? Yeah. So these are M40 nuts. How come they are inside here? I think we can use the nut as well. 1, 2, 3, 4. Thank you, thank you, thank you, Gug. Thank you, Gug man, for tuning in. Happy working, happy working. See you again, man. The motor that we are using for this is, you see, just a slim motor. Just a very thin motor. These are the slim LDO slim power. LDO 1.8 degree slim power. Since the dock slide will be running horizontally, you don't need a lot of power. So 2 will be, this slim one should be enough. One, two. So the motor wire will be going that way. Yeah, correct. So this one will be down here. And 2. Right. Just turn it around. Let's do the other side. One. Wires on the right, correct. And we will also be looking to try to enclose the entire printer. So we will see hmm, how we can, because the back here, the spool mount is already over, but we'll see how we can enclose the entire printer. Not that difficult. Okay, now I think we can install the micro switch and then rails. Micro switch rails. Yeah, I think we can install the micro switch mount and then the rails and then the stop. So micro switch mount here is using M3 by 8. Uh, where's the micro switch? This is the micro switch. Later we can install. We need to get switch. This is the end stop. This is another end stop. Hey, we got. Where's the micro switch mount? Over here. One, two. Okay, got it. And this will use M3 by 8. 3 plus 3. M3 by 6. For this, okay, use M3 by 6. I think we have it inside here. Why not putting the spools on the side? I mean, you can put the spools on the side here as well. The reason why I put the spools right behind here is, number one is shorter filament path. That means just from here direct up to the PTFE down here, right? So it's much more shorter rather than you have it going this way. But by having the spool on the side, you can enclose and then just put the spools on the side. It's also better. It's good. I also don't know why. If you put the spool on the side, 1, 2 here, yeah, can also actually. I also don't know why I decide to do this at the back here. Maybe I should just change. I will see how it goes. Initially, I think I want to do that. Just put the spool on the side. Then maybe just have a PTFE fill it up this way, going to the umbilical down here. I mean, yeah. What did I think? It's a good idea, man. Proceed. Thank you. I will try to change the design. Can change the design to have the spool on the side instead, so that you can enclose. Behind here got nothing. Yeah, correct. You only need PTFE for the spools, right? So if I have the spools at the side here, one here, then we can just make an entrance if it's enclosed. The enclosure will at the back. Yeah. I didn't think of that. Just a two spool holder. That's much easier than painting this. Yep. I think it's possible. Very good. Thank you for the suggestion. Totally didn't think of that. Yeah. I will try to change the design. I mean, not difficult. Just remove this back. So you don't need that. Nothing major. Only the back here. So no parts are touched. So now, is it this way? Yeah. Okay, got one down. So for micro switch, you can use just one micro switch since it's moving horizontally. It's much easier to calibrate them. So you can use just one micro switch, not like if you have the dog slide moving vertically, then you might need to for left and right. But this one, since it's moving horizontally, I think previously we also used one micro switch. So for the end stop of dog slide, and no issues there. Right? This is how long? How long is my rails from the previous one? 124 mm. What's the rails here? 120. Okay, so mine is longer. This is from previous one. So doesn't matter if you have 120 as well. No problem. MGN7. Do I have MGN7? What's this? MGN9. MGN9. I think it's this one, right? MGN9C. Yep. One. Then the other one is this. Yeah. So we're going to put the rails now. Huh? All right. Okay. Rails are centered. All right. Eh? Okay. Okay. Oh no. This one is not. Okay. Now where did I drop my? Oh yeah. Okay. This is the rail stopper. Okay. All right. Print the dog slide holder instead of buying new extrusion. Uh for this for the dog slide frame itself, I don't know if you can. I mean, you can print it, but number one is there will be some force pushing on this frame. When you are doing tool change, because the dogs are on the frame itself, And when you tool change, you are applying some pressure to push the dogs, because the dog need to push the lock plate, right? So you are putting some pressure, so there will be a bit of push to the right here. So if you are printing them, but it's quite long also, so I'm not sure whether you rather print than just buy a new extrusion. I mean, it's only 4 extrusion, but you can try it if to print it. This will be, what's the screw size here for this? M3 by 8. Okay, M3 by 8 is in my screw box. This is Oreo. Oreo. Okay, M3 by 8. So I need 2 of this. This is just the rail guard. Okay, so I can remove this now. All right. Woo. For the other side, I have. Let me keep my screws first. I need to find a organizer for my screw. Or I keep inside a box like that. Okay, let's turn it the other side. I think I will follow your idea. Mount the spool on the side. Just need to change. Thank you again. Close it. Close it. Close it. It's quite fast actually. Now only 11:30. 1 hour. 1 hour we already did a lot of. So it's quite fast. Okay, I haven't put the rails. Put the rails first. One, two. Put the rails in. Make sure they are centered. Okay. That looks very, very centered. Okay. Got one in. The other one is there. Two in. Okay. Okay, I have the rails in. Let's put the rail guard, rail stopper. Right. Okay, rails are done. This one way I will remove lah. This time I will remove. Rails are done. Looking smooth. Looking good. Now, I think we can do the mounting. Let's check the mounting. This is the mount. So we will need, what's the screw down here? M3 by 8. We will need 4 M3 by 8. M3 by 8, 4. Okay. Yes. 1, 2, 3, 4. 4 M3 by 8. Let's find the mount. Is it this? No, this. This is the mount. Yeah. So for this one, I think the other side. This one. This this is for the right side. For the right side, yes, it's this one. All right. Ooh. So for the other side, I don't know whether you can see it. Let me zoom it. You know, if I zoom it this way, you guys can see it. So let's do this side. Get another 4 M3 by 8. Now we're going to do this side. So we're going to put it this way. See where's the hole. Yeah. Okay. One, two. Udah. All right. Why is this a bit rough? Is it because of the... Oh, looks like it's rubbing down here. Let's try to file it a bit. I think we need to remove and file it a bit because there's a bit of a warping. I print this part. think I never reprint because of the filament. I'm out of filament. That's why I never reprint this. Hmm, but now seems okay. I think should be okay lah. Hmm. You'll be grinding too much. Actually, no lah. Doesn't matter lah. Once it's grind, you will be smooth lah. Okay. Now let's put the idler mount. Oh, but for the idler mount, don't know which side yet. Idler mount will need the M3 by 10, M3 by 10. This is M5 by 20. Okay. M3 by 10 to M5 by 21. This is the idler mount. M3 by 10 to 3 by 10 and 5 by 20. Let's try to find. And have also bought the mellow canvas hub for this is for 4 tool head, just nice. So this will fit just nice. M5 by 20 button head. 5 by this is 25. Yep, 30. 5 by 20 must be shorter. This M5 by 16. Oh, I don't have M5 by 20. This have, but socket head. Never mind, can use socket head also. Not a problem. M5 by 20 socket head. Should be button head, but I don't have button head. So I just use socket head. M5 by 20, we need two. Two. And then M3 by 10, we need four. M3 by 10 is 1, 2, 3, 4. And then we will need the pretty nut is 2, 4. Pretty nut. 1, 2, 3, 4. Okay. Let's put in the idler first. Need to idler down here. So yeah, I'm going to use them inside. All right. I forget to put in the. Oh, cannot put the idler first because we need to screw in. Because we need to screw in first. Where is my peanut? Oh, down here. My cat is going crazy with the plastic. Eh? This is M4 so why did I mix so much? Okay. Where is the placement of the idler? The idler should be above the stop. Okay. So the idler should be above the carriage module. Because this thing will need to reach up to here. The belts going down there. All right. Okay. Now then you can put in the idler. Okay. Next, we do the idler for the other side. For this side. Woo! It's 11:45 p.m., man. Woo! Okay. Okay. Alright. Adalah fix. Let's put in the pulley. How much does the pulley move out? Is it? Oh, okay. Yeah, exactly at the end, right? So it's easy. Right. Okay, pulley done. Belt. I have to use spare belts. I have spare belts, so I'm going to be using them. Let me keep this first. We have installed the rails, so there's no need for rails. Belts. Let me find my belts. Where are all my spare belts? Oreo! Hmm. Hold on, I dropped all my things. Got some my cat. Okay, where are my belts, man? Where did I keep my belts? Don't see my belts. Nope, those are servos. What is this? Magnets. Ah, here. Oh. Oh, spare belts coming. What is this? 10 mm or 6? 10? 6 mm? Yeah. 6 mm belts. The other one is 6 mm as well. Okay. Where is the? I need the belt. This belt belt grabber. Okay. What screw do we need for this belt grabber? M3 by 30 and M3 by 20. M3 by 30 and M3 by 20. Oh. M3 by 30 we have here. M3 by 20. Right. And we also need the okay, this is the belt tensioner. Let's put the belt in first. Oh man, this is so difficult. It's too small. Oh, it's so small. This is not my original belt grabber. It's from I think from Red Rig. I copy this from Red Rig. But the belt is so small, the belt slot. The belt slot is so small. This one is too small. I'm going to reprint this piece belt. This belt clip too small. So we don't do the belt today first. Belt clip is too small. It can't even go inside this. Hey, yeah. Let me put this M3 by 20 first. Now it's 11:57 guys. I think after I install this in a while, we're going to call it a day. Why do I use M3 by 20 down here? So long. Don't need M3 by 20. I thought it's M3 by 20. This is M3 by what? M3 by 20. Let me check again. Yeah. Why does it go in until so long? No. This is only M3 by 15. M3 by 15 only. M3 by 20 man. M3 by 15 don't have. M3 by 16 can. Can use M3 by 16. right? Let's put in the other one. 16. Oh man, this thing break off. Break off. Okay, so that means I will need to reinforce this part a bit. Because this part will be pulling. Yeah, I will need to reinforce this part. Okay, this part need to reprint, guys. And I need to reinforce this part. This section right here, let me show you. Okay, so this section right here, when I try to screw in, let me isolate. This section right here, when I try to screw in, this part break off. This part. So I will need to increase this height a bit, maybe. Maybe how high is this? What's the from here to here? 1.3. So I can raise it another 0.7 maybe. So make it 2 mm. Let me see. Yeah. So this is much more thicker. Because we are printing it this way. What is this? What kind of view is this? Orbit? Okay. We are printing it this way. This orientation. So this is layer line. So this part tends to break off. So we need to make it thicker. Let's give it another 1 more mm. So if we make it 1 more mm down here, here's thicker, less tendency to break off. So that means from original just now, what's the difference in height? From here to here, 1.7. So we increase it by 1.7. This side as well. Okay. This side break, so I will need to reprint this side. Let's reprint both right and left. Right, and where's the left? Left will be here. Okay, so these two will need to reprint. Okay, so I think we can stop here because we done almost everything. I will remove this spool. I will remove the spool mount and change it to a side mount. That's number one. Number two, I will reprint the dog slide mount because we need it to be thicker. Number two. Number three, reprint the belt grabber because the belt cannot go in. The slot is too thin. So we need to expand the slot a bit. What is the cheapest tool head configuration you can buy for Linux tool head? The cheapest number one, let's talk about extruder. Cheapest extruder, just buy the BMG gears and do up this. Hold on. And do up micro Shepa micro. BMG gear, Shepa micro. I think the BMG gear I bought, this is hardened gears, hardened steel gears. $4. So $4 for the gears only, just print and you got the Shepa micro. That's number one. So for extruder, very cheap, $4. Fan also is very cheap, hot end fan. Stepper motors, I recommend LDO because I have problem with some cheap stepper motors. So LDO stepper motors is my recommended motors. And then let's talk about hot end. Hot end, there's a lot of variety, but recently I just bought the TZ 3.0. This is a single piece nozzle. One is only $22, 22 Singapore dollars. So let's say 20 here. Then for the extruder, $4. So hold on. Okay. So $20 for the hot end, for the extruder, $4. Hot end fan, I think also cheap. Or toolboard. Toolboard, the cheapest will be EBB 36, the V1.2 toolboard, very cheap. I think it's only about $12, $11, $12, something like that. And toolboard, extruder, hot end. Basically, yeah, that's it. So that's the cheapest configuration. So one tool head maybe about 20, 30, 40, $40 per tool head. I mean, plus all the hardware, the magnets, everything. So about $40 per tool head. So that's one tool head. I have four of the tool head here. By the way, okay, this tool head, let me try to explain a bit about this new tool head. This is I'm trying out this next new tool head. This is the Linux Tiga. We call it Tiga. So what's the difference in this tool head is this I'm going to test. This is Proto Extruder 2.0. So also the same, I buy the gear, then printed the extruder. Let me turn off this, hold on, fusion first, yeah. So I buy the gears and then I printed the extruder itself. So this is the Proto Extruder. This is the skeletonized view. So as you can see here, yep, it's turning. And this tool head, why it's new is number one, we already scrapped off the dock sense on the dowel. We just put a micro switch down here. So because somebody said it's too tedious to do the dowel dock sense, right? So we only have the micro switch already. Here one, still the same. Here one. Okay, the difference for this tool head, this is the Tiga tool head I'm testing right now. Let me open up so that you can see. Hold on. Let me bring my cigarette also. When I need to explain, I need to smoke. Right, let me do some explanation. Yeah. Okay. Number one is the cowl. Wait, okay, down here, yeah. So you can see. So this is the cowl. What's the difference is we are not using the hinge anymore because there are few feedbacks that the hinge tends to break down here. So we're going to use screw. So if you remove these two screw, one, two. So if you remove these two screws, oh alamak, this one don't have, sorry. Wait, I cannot use that as a sample. I have to use this because I haven't do properly that one. Okay. Hold on, let me drink some water. So if you remove these two screws, one, two, you can just no, I will take out. Okay. Two. Okay. So if you remove the two screws in front, you can just pull out the cowl this way. This totally disconnected. So very simple. You just take out, you just can place one side. You are exposed to your hot end, your extruder and the back plate. So you are left with this. This is the cowl. How the cowl fan and the cowl LEDs are connected is via this DuPont pin, if you can see. Hold on. There are 5 DuPont pins. Wait, this pin come. Okay. There are 5 DuPont pin down here. Let me see. Yeah. So these are all connected with the DuPont pin down here. So there are 5 pin right down here. 3 for LEDs, 2 for the fan. So basically this is just the cowl. You don't have to do anything. Just plug out. Then your extruder is free already. And the extruder itself has the 5 DuPont down here as well. So when you connect it, they will be connected to your toolboard. From behind here, connected to your toolboard. That is number one. So easier maintenance. If you need to do anything, you just take out this. And let's say if you change to a high flow hot end, you need the high flow cowl. So you just put in the high flow cowl. If you change to a ultra high flow, you just put in the ultra high flow cowl. So the cowl is switchable. So you can use for whatever tool head you have. That is number one, the changes there. So 5 pin DuPont down here and the 5 pin DuPont down here as well. So it's connected. So it's very easy. You just take out. The cowl is that way. So now let's talk about the tool head side. So the hot end and the extruder. So here you have the dock sense switch down here. You just screw into the back plate this way. Oh, there you go. So you just screw into the back plate this way. That's number one. Number two is you can change your hot end without needing to take out anything. So there's 2 screws down here below. One down here, right? One. Then the other one is here, 2. So there's 2 screws down here. If you remove these 2 screws, the whole hot end assembly will come out, and then you can put in the other extension, whatever hot end you have, put in the other hot end. Maybe you want the ultra high flow or revo boron lower flow, normal flow. So you just remove the hot end, then put in the other hot end. So nothing else need to be touched. So that's the good thing. The only thing that you need to change is this base mount here. If you change your extruder. So this is the proto extruder. So if you can see, I don't know whether you can see. So this is the proto extruder base mount with the TZ V6 3.0 hot end mount. So if you remove this, you will get something like this. Let me show you this. So same thing, take out here. 1, 2. So same thing, you can see here. So this is a Shepa Micro base mount with a CHC Pro. So this is a CHC Pro. So if you remove this, you put in the TZ mount, you can mount it here already. So you don't need to remove anything on top here. Everything is untouched. So that's the difference between this tool head and the previous version. So this is much more easier to maintenance or change or anything. So this is the complete tool head down here. This is the complete tool head. Let me put in. So all are DuPont mounted, so that the connection are there. So you just put in the cowl, and then you screw in. Right. So that's it. This is the printed PUBG adapter. This is not the PG7 gland. This is the printed PUB. So that's it. This is the tool head down here. And for the dog as well, there's some changes to the dog, as you can see, but not really a lot of changes. It's just the way the nozzle blocker are mounted. So this one, you can move it up this way or down to adjust. For the nozzle blocker, you can move it front or back to adjust. For this side is the same. You can adjust this way. So all 3 direction can be adjusted easily. So this is the new dock. Just a simple one this way. Right? And the and the drip tray also just plug in this way. You can take out. Drip tray is together with the A1 brush, A1 nozzle brush. We just put it this way. So that will be the new upgrade. And also you can see there's no M3, M6 by 3 magnets here. Even on the tool side, there's no M3 but M6 by 3. Why? Because you can see that after a lot of testing, I can see that this one is good enough to hold the tool in place really. Without the M6 by 3, you can see here. I hold the dock this way from the side. The tool head is not dropping. And if I remove it this way, can take it out, put it in bank, you can see that can hold the tool head. So you don't need the M6 by 3. Right? I mean, that's the only difference, the changes for this Tiga tool head. I will test it and then I will release the file. Very, very simple, very easy. Maintenance also very easy. Anything you need to change also very easy. Right. That's it. Okay. Okay, so I need to print some things tomorrow. And then the next stream, we can already continue. I need the belt also. I don't know whether I want to use this belt. These are those with the steel core inside. I don't think it's good. I mean, it can be used for dog slide, not a problem. Because dog slide doesn't need anything much. Maybe I just give it a try and use the steel core. Alright, guys. Thanks for tuning in all this while for this stream. And we'll catch you in the next stream. So far, everything, let me finalize. So far, everything has been built. This one, let me zoom in. Alright. So we have already installed the frame itself. Number one, we have installed the frame from the side. Let's do it from the side. This way. So we have installed the frame in front. The bed can move, not a problem. We have installed the dog slide mount. We have installed the idlers. We have installed the motors, the motor mount. And for the spool holder mount, I think I will follow Closey idea. Closey 4334. Yes, I will follow your idea and try to have the spool mounted at the side, so that if we were to enclose the printer, it's much easier, because this one protrudes back a bit. So I'm going to change this. That's a great idea. Thank you again, Closey. And yep, I think that's all. We will continue again with the build. The next, for the carriage, everything is okay. I already tested with the tool. Yep. So looks solid. Everything looks solid down here. Can bring up and down, and disengage also very solid. Don't know whether you guys can see the way that the duct from the fan goes down here all the way and down to here. So this is the new. This duct can just be removed this way. This duct is by magnet. So if you just pull down the duct, it can be removed and try to pull down. Yeah. So the duct can be removed. So you just need to put the duct in this way at the side here. Oh, I see. Not see the. Let me see. Yep. Yep. Okay. Thank you for the stream. No problem. Thank you very much for tuning in. Hold on. Thank you very much for tuning in. Those who catch the stream. There's some hiccups this mount, the dog slide mount break. We need to reprint that. We also need to reprint the belt clip, the belt grabber, number one. Number two, we need to reprint this dog slide mount. And then we will need to get some belts, or no need belt, we can use this. What else just now? Did we miss? Here, correct. Here, correct. Here. Oh, we need, I will remove the spool holder mount. Install the side spool down here. Two here, two there. So we make it 4. Yep, basically that's it. Nothing else. Then we can proceed to do another stream. And this cat, for this cat is already inside GitHub. I already released the Lineux Sling cat inside GitHub. You can check inside, not GitHub, inside Discord. I've released this Linux Sling cat inside Discord. You can get it from there. It's inside the printer build, under my printer build. It's all inside. There are some changes. I think there are no changes actually, but I'm going to make some changes because of this, the way the spool mount. So I do some changes and I will update that. Thank you again, guys, for tuning in, and we'll see you on the next stream. All right. See you guys. Thanks.